And the big thing we had with our percents was we had converting a fraction into a percent. We had something like this. 3/5. We wanted to convert that into a percent. We think of it as 3 out of 5. A percent is always out of 100. So what we're asking ourselves is how much out of 100 is equivalent to 3 out of 5? And we use that whole idea of you could use equivalent fractions if you wanted to, but it's easier, quicker to use a shortcut, which we talked about, was cross multiply and divide. Helps if I put the extra 0 in there, doesn't it? There we go. So what two numbers do we have to multiply here? What two numbers are on the diagonal together? 100 and the 3. So we get 300 there. And then we divide by the 5, gives us 60. So that tells us that 3 out of 5 is equivalent to 60 out of 100, or 60%. So when we're looking at that 60%, 60 out of 100, what we're looking at is we're looking at a large group of something. That's representing the whole thing. That's what the 100 is representing, is the whole amount. Now, it may not be 100, it may be more than that, but it's being represented by the 100. And the percent, in this case the 60, is representing a small piece of that somewhere that we are focusing in on. And if we keep that in mind as we do our calculations with percents, it helps us to match things up. So let's start out with some basic calculations first. Let's look at something like find 45% of 60. So the 45% means 40 out of every 100. So 45 out of 100, I should say. Now it's asking find 45% of 60. So we have to ask ourselves, there's two other numbers in all these problems other than the percents. In this case, one of them is the number we're looking for, what we're asked to find, and the other one's the 60. So we have to ask ourselves, which one is the piece that we're focusing in on? That's represented by the 45. That's that portion that we're interested in. And which one represents the whole larger group, which is the 100. We'll match up with the 100. So that 100, as we said, is the whole group. Sometimes, if we're looking at changes, that could also be thought of as the beginning or the starting point. So in this case, we're asked to find 45%. So what it's asking us to do is find that number that represents the piece that we're looking at, the same as the 45%. So our missing number goes up here. Of 60, we can think of that as being out of 60, which implies the 60 is the larger group that we're trying to find it out of. So that goes on bottom. So now we can cross multiply and divide to find the missing number. What two numbers do we multiply here? Yep, 45 and 60. Good. What does that give us? Well, 2,700 first. Then we divide by 100 and it gives us 27. You're just a step ahead of me. Perfect. So we get the 27. Just a little bit different way of wording it. Blank is 100 and we'll go 40% of 90. So again, we have the 140%, which is 140 out of 100. So if we analyze that for just a second, 140 out of 100. 100 again is that whole group of things we're looking at. We want to find 140% of them, or 140 of them. So what we're looking at, the piece we're focusing in on is actually bigger than the whole group. 100% would be the whole thing. So on the other side over here, we have to put in our two other numbers. One of them is represented by the missing number. Does that represent the 140, the piece that we're focusing in on, or does that represent the whole amount, the 100? Well, it says blank is 140, right? That's implying to us that that missing amount is the matching up with the 140. Again here, of 90, we can read that as out of 90. So 90 will go on bottom. So when we cross multiply and divide, what two numbers do we multiply here? 140 times 90, which is 12,600. Good. And we divide by 100. 126. Now I talked about those benchmarks a little bit on Wednesday. We did the 1%, 10%, and so on. Here's another one. 100% is the whole thing. So when we have 140%, we need to make sure our answer is bigger than the whole thing, bigger than the 90% we started with. How about we have 30% of 70 is blank. This one's worded a little bit different, but it's really the same problem. So we've got 30% will be 30 out of 100 again. So on the other side, we have the 70 and we have the missing number. Which one goes on top? Well, this one's a little tougher to look at. Maybe it's easier to look at what's on bottom first. If I look at of 70, if I read that as out of 70, that implies the 70 has to go where?
Is it supposed to be 0.70 or 70?
That's just 70. That decimal point is just a stray mark. Is that better? Okay, thanks. So yes, out of 70 implies the 70 has to go on bottom. So our missing number has to be on top. So what do we multiply? 30 times 70 is 2100. Divided by 100 gives us 21. So it's worded very differently, but it's exactly the same problem here. 21 is 30% out of 70. How about we look at something like this? Let's say we have 32 is 80% of blank. So we still have our percent. 80% is 80 out of 100. Now we have two other numbers. We have the 32 and the missing number. Which one goes on bottom? Which one's going to go down here? The missing number or the 32? Think of this as out of blank. Implies the missing number goes on bottom this time. So 32 is 80%, implies the 32 matches up with the 80. So now if we look at this compared to the last one, these numbers are in different places. Here we had the percent and we had the bottom number. Here we have the percent and we have the top number. So when we set it up, we had to put the numbers in different spots. But our calculation is still going to be exactly the same. It's still going to be cross multiply the two numbers that are on the diagonal with each other and then divide. So 100 times 32 is 3200, and we divide by 80, gives us 40. So 32 is 80% out of 40.
Can you give me a reason why I got 37.5?
You must have 37. Did you 32 or 30? Okay. Okay, that'll do it. So anyway, let's look at 25% of blank is 17. So here again, we have our percent, 25%. It's 25 out of 100. Just come on. Where's the 17 go, top or bottom? Somebody said top. 25% is 17, implies the 25 and the 17 go together. Again, of blank, if you read that as out of blank, implies that missing number's on bottom. So again, we multiply the two numbers that are diagonal to each other. 100 times 17 is 1700. Oops, no extra zero. Divided by 25 gives us 68. Perfect. Well, we can run into a problem like this. $14 is blank percent of 70. Now, so far in every problem, we've started out with the percent. Here, we don't have the percent, but it's not going to change anything. It's just blank over 100. Whatever that percent is, we know it's going to be out of 100. Equals, Now we have the two numbers again. This time we have them both instead of a missing one. We have 14 and 70. One of them matches up with the missing percent. So it's going to go on top. Which one is that? 14 is blank percent. So 14. Yep. Of 70, if we read that as out of 70, implies the 70 goes on bottom. So what we're asking now is, how many out of 100 would be equivalent to 14 out of 70? Perfect. Yeah, 20. So to find that, to calculate that, we're going to cross multiply and divide. You'll notice again, there's different numbers. Every problem we've done so far, we've had both of the numbers in the percent side, and we had one of the numbers on the other side. This time we just have the 100, and we have both of the other numbers. But the calculation is still the same. There's two numbers that are diagonal to each other, the 100 and the 14, so we're going to multiply them. This is the 1400. Then we're going to divide by the third number, the 70, and yes, that does give us 20. So 20 out of 100 is 20%. 14 is 20% of 70. Or we could run into blank percent of 90 is 63. So again, we're missing our percent. So we'll start off with blank out of 100. Now when it's worded like this, it's a little trickier to match them up. Which one goes, and I'm going to ask the easier one first, which one goes on bottom? Okay, 90, perfect. Out of 90. Of 90 implies out of 90. So the 90 goes on bottom. So the 63 has to go on top. Perfect. So now we cross multiply the 100 times the 63 is 6,300 and divide by the 90. So 70 out of 100 or 70%. Any questions on those? Now I know a couple of you have been doing, I can catch from what you were calculating, doing these calculations a little bit differently, using something called the rate method of percents. What the rate method involves is converting your percent into a decimal. So here 45% is going to become 0.45. And when we do that, then we take that decimal version, which is called a rate, and we're going to take, in this case, we take 60 times the 0.45, and it gives us 27. So it's a really quick and easy way to get our answer. The second one here, 140%, becomes what is a decimal? 1.40 or 1.4, either one. And that would be 90 times 1.4 is 126. So again, that's a pretty quick way, an easy way to get our answer. And the next one would work the same. One of you guys walk me through it. Tell me what to do. 0.30, yep. 70 times 0.30 is the 21. Perfect. The problem with the rate method, the reason I like the proportion method so much is, yeah, the rate method looks quick and easy, and for those first three it is. But the proportion method, it's always the same. Once you get the numbers into it, it's always just multiply the two that are on the same diagonal, then divide by the third number. The rate method, we'll run into problems like this fourth one. 80%, of course, is 0.8 as a decimal. I'm not going to multiply by 0.8, however. I'm going to take 32 and divide by 0.8 to get the 40. So if I'm going to use that rate method, I have to be able to look at the problem and decide, do I multiply or do I divide? What am I going to do with this next one down here? 25% is 0.25. Is it going to be 17 times or divided by? Careful. Divided by. To the 68. So when we have that rate method, you have to be able to look at the problem and decide, am I dividing by the rate or am I multiplying by the rate? And then there's even a third type. This one down here, I don't have the percent, so I have nothing to convert to a decimal. I have the two numbers, the 14 and the 70. So I have to look at those and decide which one is the piece that we're concentrating on and which one represents the whole amount. Well, in this case, the 70 is the whole amount, and the 14 is the piece we're concentrating on. So we divide. 14 divided by 70 is 0.2. And now we have to do our conversion to change that rate into a percent of 20%. Same down here. The 90 is the whole amount, so we're dividing by 90. 63 is the piece we're focusing on. You divide it out to get 0.7, and then you convert it into a percent of 70%. So that rate method, if you get good at it and you can see it, it is quicker. To be honest, that's the way I do it because I've done enough of these problems where I can look at them and I can see which way it has to be done. When you're starting out, however, this proportion method, from what I've seen, usually produces a lot fewer mistakes. Now, the proportion method also has the added advantage of when we do word problems, it allows us to just match things up. Let me show you what I mean. Let's do a word problem like TMP Corporation estimates 2% of parts will be defective. How many defective parts are expected in an hour where 2,800 parts are produced? So just like with the other problems, if I have a percent, I'm going to start with that. So we have 2% here, which is 2 over 100. But since this is a story problem, a word problem, I know what each of those numbers represents. The 2 represents the piece we're concentrating, the focusing in on. In this problem, what is that? What does that 2% represent? The defectives or the failures. The 100 always represents the whole amount or the group, the larger group that we're looking at. In this case, what is that 100% representing? The total parts, right? And the words you use don't matter. Total parts, all parts, however you want to word it. It's everything that was produced in that hour. So now on the other side of this, in our other fraction, we have to ask ourselves, we have the 2,800. Does that represent the defectives or the total parts? Total. So the 2,800 goes here. It has to match up with the 100 because they both represent total parts. Perfect. We cross multiply 2 times the 2,800. We divide by the 100 is 56. So they're expecting 56 defective parts. Yes, sir? Well, that's just per hour. The hour is just narrowing it down. I could say the whole shift or whatever. That really doesn't affect it much there. Yeah, you're right. Let's take a look at this. What's that? Okay. Let's take a look at another one. Say LMP company estimates gross profits as 12% of net sales. Find net sales for a week where gross profit is estimated at, let's go $38,400. Now here, once again, that week is just in there as an arbitrary time frame. Doesn't affect the percent calculation at all. But we do have a percent in this problem. What is the percent that shows here? 12%. Good. So we'll start as 12 out of 100. So now again, the 12 is representing the piece we're focusing on. What does that 12 represent? We've got two things in this problem. We've got gross profits and net sales. One of them is the piece we're focusing on, and one is the larger group that piece is a part of. So when we look at this, the wording makes it a little tricky, but which one is the larger piece? Net sales would be the larger piece. And we're using that net sales, out of that large group of net sales, we're focusing in on the gross profits. Net sales is the whole amount of money we're bringing in. Gross profits is what we're actually making above our expenses. So the 12 or the 12% represents gross profits. Or you could just say profits or whatever you want. 100 then, the larger group that we're viewing that out of, is the net sales. So on the other side of this, we have the 38,400. Which one of those two does that represent? Gross profits are estimated at 38,400. So that represents the gross profits. Now, before we cross multiply and divide, we really should ask ourselves another question, and that is, this is the net sales down here. Is that what we're looking for in this problem? Yes, it is. So let's cross multiply and divide. 100 times 38,000. I lost my 4 there somewhere, didn't I? 38,400 divided by 12. Gives us 320,000. So net sales for that week must have been 320,000 if they estimated gross profits at 38,400. Let's say Tim receives a $3,500 per year raise. If his old salary is $40,000, what percent raise did he receive? So now in this one, we don't have the percent. So we're going to set it up as blank out of 100. Now we said before, 100 is the whole amount, the larger group, or the other option is it's the beginning amount, the initial, the starting point. In this case, do we have either of those? We have a starting point. The 40,000 is the starting point. That's where this all began. That was the old salary. So that has to match up with the 100. So the 100 is representing the old salary. The percent that we're looking for is going to describe what? What percent raise, exactly. So the percent is representing the raise. The dollar amount has to represent the raise as well, and that is 3,500. So to find that percent, we cross multiply. 100 times 3,500 divided by 40,000. Gives us, what, 8.75? So 8.75 out of 100, or 8.75%. I'd be happy with that raise for the year. Okay. Some of these problems are a little bit trickier than what we've been looking at. We can run into something like this where, well, let's say that 9% of parts produced are defective. During a shift where 8,000 parts are produced, how many good parts are completed? So we have a percent in this problem. We have 9%. If we look at this, what is the 9 representing here? Defective parts again. You got it. That's our defective. So the 100 must represent the total parts produced. So on the other side, do we have either of those numbers? Do we have the number of defectives or the number of total parts? Yeah, we have 8,000 parts. That is the total, right? 8,000 parts produced. Now, before we cross multiply and divide, are the number of defectives what we're looking for here?
No.
No, we're not. But if we knew the number of defectives, could we find what we're looking for?
Yeah, 7,280.
Okay, perfect. Yeah, if we know the defectives, we can find what we're looking for by subtracting. But I wanted to ask that question because once we cross multiply and divide, it's real easy to take that answer, write it down, and assume we're done. So we have to break these down before we get too far into them. 9 times the 8,000 is 72,000. Divided by the 100 is 720. And you're correct. To find the actual, that's the defective parts produced. We want to know how many good parts are produced. We're simply going to subtract. 8,000 minus 720 is 8,280. Perfect. 8,000, sorry. Let me try that again. How about 7,280? In a problem like this, that worked out okay, but we're going to run into problems where we have to analyze it a little deeper than that. Let's work our way up to one of those. Now, for you guys, if you decide to go into the construction industry, you're going to end up with suppliers that you do a good share of your business with. And if you do enough of business with a certain supplier, they're going to give you a trade discount where you might receive, well, let's say you get a 8% discount from a supplier. Just because you've done enough business with them every year, they know they're going to make money off you, so they're going to give you that little bit of a discount to keep you coming in. So how much do you pay for items? We're going to say with a list price. By list price, we just means what price is listed on there for every other customer coming in off the street. So what would you pay for items with list price of $3,800? So here we have that percent, 8%. So it's 8 out of 100. What's the 8 represent here? The discount. Perfect. Now, the 100 represents the whole amount. The whole amount here would be the list price, the amount before the discount. On the other side, do we know either of those numbers, the discount or the list price? The 3,800 is what? The list price. So we cross multiply and divide. 8 times 3,800 divided by 100 gives us 304. Is that the number we're looking for, though? That is the amount of the discount. Is that what we're asked to find? No. So what we have to do is take our list price of $3,800, subtract that 304 from it, which will give us $3,496 is the amount we paid. That's what we're asked to find. This type of problem occurs often enough where we need to look for some mechanisms to help us solve it. This is what we call a percent decrease problem. By percent decrease, I mean we're starting out with a whole amount and we're removing a certain percent of it. A discount is a percent decrease because we're taking that discount and we're removing it from the full price to get what we're going to pay. So here the $3,800 was the list price or the full price, whatever words you want to use again. The 304 is the discount. We're subtracting that discount. Then we're getting the amount we paid. And anytime we have a percent problem, every item in the problem is described by two numbers, as we've said. We have the percents, and then in this case, dollar amounts. In this problem, we were given the full price, or the list price was $3,800. Oops, was the $3,800. That has to be 100%. The amount of the discount was 8%. With that information, we could have calculated that the amount paid is what percent? 100 minus 8 makes 92. If you think about it, it makes sense. If the whole amount is 100% and you're removing 8% or a discount of 8%, what's left over is 92%. So what you could do with a problem like this, rather than finding 8% and having to subtract it back out, you could just find 92% of the 3,800. If we cross multiply and divide here, 92 times 3,800 divided by 100, we would get 3,496. So we can get it in a single calculation. In a problem like this one, it's about the same amount of work to go either way. But there are problems, like the next example I'm going to show you, where we have to be able to look at it this way. For example, let's say that after a 4% discount, you pay $644. Is that going to work? Let me adjust that a little bit. Oh, $672 will be easier to work with. So after a 4% discount, you pay $672. How much did you save? So here you have that 4% is 4 over 100. The 4 represents the discount again. The 100 represents the full price, or the beginning price. Now we look at this problem, we're asked, how much did you save? What is that? Is that the discount or the full price or something else? Well, how much you saved would be the dollar amount of the discount, right? So that's this amount right here. That is, so the amount of the discount is what we're looking for. The problem with this is the 672, is that the full price? No, it's not. That 672 is what we paid after the discount. So we don't know this number right here. So we can't use this percent. But if we think about it in the way I showed you just before, here we had the full price. From that, we're going to subtract a discount to get an amount paid. every item in that problem has a percent that describes it and another number, and it's still dollars for this one. The full price is always 100%. What was the discount in this problem? 4%. So what percent is the amount paid? 100 minus 4 makes 96%. On the other side, what dollar amount do we know? The 672 represents what? After discount, the amount you paid. So we have, for the amount paid, we know the dollar amount and we know its percent. The next question is, which amount are we looking for? Are we looking for the amount paid? Yes or no? We're looking, or the, sorry, not the amount paid. Are we looking for the full amount? No, we're looking for the amount we saved. We're looking for the amount of the discount. When we're working with percents, everybody gets locked into, we have to use 100%. We have to have that percent over 100. And if we're looking at the whole thing, yes, we have to have that 4% is 4 out of 100. But here we're not, that we don't have the whole thing. So here we're looking at relating the discount to the amount paid. So we're not relating that 4% to the whole thing. We're relating that 4% to the other 96%, which is what we paid. So here we can set this up. 4% discount relates to the 96% paid in the same way as the $672 paid is going to represent or relate to the dollar amount that we saved. Now this confuses a lot of people. It's a percent problem, but there isn't a 100 on bottom. What's that? 2688. Let's try it. 4 times 672 divided by 100. 2688. Or sorry, not divided by 100. What did I do wrong there?
96.
Should have been divided by 96. Yep. I made the same mistake you did.
No, I didn't make that mistake. Yeah,
Let me try it again. I missed a key there. 672 divided by 96. There we go. $28. So $28 is how much they saved. Now, one of the keys to these problems, if you're not sure if you did it right, add it together and work it backwards. So here they saved $28. They paid $672. Full price must have been $672 plus 28. Must have been $700 if we did this correctly. So if we want to work this backwards, if I find 4% of 700, will that give us the 28% that we had for, or $28 for discount? Yeah, 4 times 700 is 2,800. Divided by 100 does give us a $28 discount. Yeah. Yeah, go for it. Okay, let's look at another problem similar to that. Let's scroll down. At, say, after a 15% discount, you pay $3,400. What was the full price? In your notes, I want you to try to solve this quick. See if you can figure out what the full price was for this. If we paid $3,400 after a 15% discount. So 15% is 15 out of 100. The 15 represents the discount, and the 100 represents the full price. we are looking for what was the full price. So we're looking for the full price here. Does the 3,400 represent the amount of the discount? It doesn't, does it? So that 3,400 does not represent the discount or the full price. So what do we have to do to solve this? Well, again, if we have the full price, we subtract the discount, it's going to give us the amount we pay. Now, you don't necessarily have to write this out. I'm writing it out like this just to kind of give you an idea of where the numbers are coming from. But the full price or the starting amount is always 100%. What percent is the discount here? 15. So we subtract 15%. What percent then is the amount paid? 85%. So now on the other side, what number do we know? The 3,400 describes what? The amount paid. So the final question is, what are we looking for? Are we looking for the dollar amount of the discount or the full price? What was the full price? Yes, we're looking for the full price. So I don't need the discount. I need the full price. We could pull this out and make a proportion like we have been in cross multiply and divide, but I'm going to show you an even shorter shortcut. Right in this table, I can actually cross multiply and divide. The 100 does not have to go on bottom. It's just the relationship between the 100 and the 85 that's important here. I can cross multiply 100 times 3,400 and divide by 85. Should give me 4,000. So $4,000 is the full price. Any questions? Okay. Let's look at the other side of things. Let's say that you purchase materials for $2,400. You add 11% for handling. How much do you charge? So there's 11% here, 11 out of 100. What does the 11 represent, the 11%? The amount you're going to add, right? You add 11%. That's what you're going to add if you want to add for handling or however you want to describe it. The 100 represents the starting amount, what you purchased them for. So in this case, that's the $2,400. So $2,400 goes with the 100. That's the starting amount. Are we looking for the amount that we add? No. We're looking for how much we're going to charge. Well, if I know how much we're going to add, can I find what we're going to charge? Yeah. So I'm going to cross multiply and divide. 11 times 2,400 divided by 100 is going to be $264. So what do we do with that to get what we're looking for? Add it. Perfect. 2,400 plus $264 is $2,664. We would charge $2,664 for those materials. Let's look at what happened there now. So we had the 2,400. We added 26 or 264. And we got the 2,664. So we had a starting amount I'm going to just call that our cost because that's what we paid for it. To that, we're going to add, you could call it a markup, you could call it profit, handling, or whatever. We're just going to call it handling because that's what it's described as in the problem. And then the total is the amount we charge our customer. So again, each of these items is described with two numbers. We have a percent, and on the other side we have a dollar amount. So for the percents, the cost is the starting amount. That has to be 100%. The 11% is the handling. Is the charge going to be 89? Careful. This time it's not going to be 100 minus 11. It's going to be plus. We're adding to this. This is a percent increase problem. We're adding to an original amount. So we have the full 100% plus an additional 11%. We're going to charge 111%. So for this problem, rather than finding the $264 and adding it on, we could have found 111% of the original $2,400. And when we cross multiply and divide, that'll give us $26.64. Now again, in a problem like this, it's about the same amount of effort either way. But we can run into a problem like this one. Let's say after adding 5% for expenses, Pete charges let's say $315 for a part, for materials we'll call it. How much did Pete add to the price? In your notes, see if you can find that value for me quick. So how many of you got $15.75? Okay. Well, I know exactly what you did wrong.
What? That's not the right
That's
answer.
not the right answer, no. But that's what I expected you to get. When you jump into this one, 5% is 5 over 100. That 5 represents the amount that Pete added, right? The 100 represented the original cost, what he paid for it. Well, we're looking for the amount that Pete added to this, aren't we? So that's what we're looking for. But is the $315 what Pete paid for it? Is that the cost? No, that's what he charged after he added the amount to it. So this isn't going to work. So we look at it. We have what Pete paid for it, what his cost was, plus what he added to it. That's going to give us what he charged for it. Pete charged $315. The markup, what he added to it was 5%. So he started out with 100% was his cost. What he ended up charging was 100 plus 5, or 105%. What we're looking for is the amount that he added, the dollar amount of what he added, as we said before. So we don't need the cost. So here again, this is like that problem a few examples ago where we're not comparing anything to the whole amount. Here we're comparing the piece that he added to the total after he added it. So we're comparing the 5 to 105, not to 100 anymore. So now I'm going to cheat and I'm going to work right inside this table. I'm going to cross multiply 5 times 315 and divide by 105. It gives us $15 is what he added. Now if you got that $15.75, let's take a look at that answer for a little bit. Because I expected a lot of you to come up with that. So if we're trying to verify if he added $15.75 to this, how could we double check that? Bless you. Well, if he charged $315, if he added $15.75, what did he pay for it? What did it cost him? Careful, other way. We would subtract the $15.75. So that's telling us that he would have paid $299.25. Now let's reverse this. If we add 5% to $299.25, do we get back to the $315 that he charged? Let's try it. 5% of $299.25. Well, if we cross multiply and divide, $299.25 times 5 divided by 100, $14.96. If we try to add that back on to the $299.25, we're going to end up at $314.21. We're 79 cents short, aren't we? So we know this couldn't work. The $15.75 couldn't work. Let's double check the answer we got here, the $15. So if we charge $315, if the amount he added was $15, that means he had to have paid $300. So let's double check to see if we can go back up if we add 5% to 300. So 5% of 300. Cross multiply and divide. 5 times 300 is 1,500. Divided by 100 is 15. Well, we can see already if we add that back on, $300 plus $15 will get us back to the $315 that he charged. Now, I realize that in real life, you don't have time to double check every answer. But until you get confident with your calculations, it's best to do it. If you start a new job, and I've started several new jobs in my life, you don't want to make any critical mistakes in the beginning of that job. They're more concerned about your accuracy than they are about your speed. They're not expecting you to produce real fast. So take the time, double check anything that you calculate or do so that you know it's right. And then as time goes on, you'll become more confident in how you're doing it and what you have to do. Then you can skip that double checking as you know what you're doing and what the process is. Let's look at a couple more examples. I'm going to have you try these in your notes. So let's say that after an 8% price increase, TWA charges $450 for a ticket. What was the price before the increase? So in your notes, see if you can figure that out for me. So you found 8% of the 450. But the thing is that 8% is describing the increase, right?
Yeah.
100 always describes the starting amount. Or in this case, that would be the old price before the increase. Is the 450 the price before the increase? No, that's the price after the increase. So that's not what this percent is based out of. So we can't find 8% of 450. That 8% is based off of a different amount. Let's double check your answer, though, to verify. Before we do anything else, let's double check your answer.
No, mine's wrong. Don't do it.
Well, you found 8%, which was $36. So you subtracted $36 to get $414. Which again, I expected that to happen. If I do an 8% increase on 414, do I get back to 450? So 8% will be 8 times 414 divided by 100, which is going to give us $33.12. You got it. If we add that on, 414 plus 33.12 is 447.12. You can see what the problem is here is when we were double checking it, we were finding 8% of the 414. But when we calculated it, we were finding 8% of the 450. We're finding 8% of two different numbers, so it can't possibly equal out. And the problem was in the beginning, we were finding 8% of something that wasn't what the whole basis of it was. So how do we deal with this? Well, the 450 isn't the starting amount. It's not the 100%. It's the amount after the increase. So what percent represents the 450? There we go. We had the whole amount, which is 100. We added an 8% increase to it.
Yeah, but then you get 486.
Careful. That 450 represents 108%. So no matter what we do, that 108 has to be linked with the 450. What you're doing is you're sliding that 450 back down with the 100% again. 108%. Cancel, get out of there. We have our 108% is 108 out of 100. Does the 450 go on top or bottom? The 450 is linked with the 108. It has to go on top. That is the amount after the increase. The 100 represents the amount before the increase. So if we cross multiply and divide here, 100 times 450 divided by 108, we get $416.67. That is the amount before the increase. Let's double check that and see how it goes. Now this might be off by a penny or two. Can anybody tell me why? This actually, if we calculate out, is 416.66666. So there might be some round off errors. Let's find 8% of 416. Now I'm going to point something out to you here. When you calculated it and you got that $414, and your first calculation, you matched up 450 with the 100, right? When we double checked it, we matched up 414 with the 100. We were matching up different numbers with the 100%, the whole amount when we were calculating, and then when we were compared to when we were checking. Here, when we were doing our calculation, what matched up with the 100? The 416.67. When we're double checking it, what's matching up with the 100? The same number, 416.67. We cross multiply and divide here. 8 times 416.67 divide by 100 is $33.33.
Can you show me how to do that
The rate method? Okay, very good. If we want to do that with the rate method to make it go a little quicker, you started out with 100%, you're adding an 8% increase, so you're dealing with a 108%. That 108% represents, bless you, the $450. If I want to get back to 100%, I divide by the 1.08 as a decimal. That'll give me my 416.67. Any other questions? You bet. So now let's say after a 17% discount, you save $510. How much did you pay? Try that one in your notes. See what you come up with. Anybody want to give me some of their thoughts on how they approached it? This one's not as hard as it looks.
Are you sure?
Okay, for me it's not as hard as it looks. How's that? We have the 17%. 17 represents what? The discount. The 100, of course, represents full price. Do we have either of those values given in the problem? Yeah, you save $510. That's the discount. Are we looking for the full price?
Yeah.
We want to know how much you paid after the discount. So we're not looking for the full price, but we can find what we're looking for if we know the full price. So we can cross multiply and divide. 100 times 510 divided by 17 should be $3,000. You look confused. You okay? Okay. So $3,000 is our full price. How do we get our answer from that? Well, after the discount, we would have paid the full price minus what we saved. So this is going to give us $2,490 is the amount we paid. As you can see, these percents are a lot more complicated than they look. We're going to do a little bit more work with these next week on Wednesday. Now, Mr. Berry, am I right? Is it the 13th of October you guys have in-service? If I remember right? I knew there's another Friday coming up where we don't have class.
Well, it'll be next Friday.
Next Friday?
Homecoming.
Okay.
Cut fest and all
Okay,
that.
that's the 6th or 7th?
That would be the 7th.
7th?
And then the 14th, we have parent-teacher conference.
Okay.
On Friday.
So it looks like then we'll probably be having our Unit 1 test will be on the 12th. Or not the 12th, 19th?
19th
That'd be
will be,
Wednesday after.
yeah.
Okay. So just so you guys know, Unit 1 test will be coming up a little more than 2 weeks from today then.
There will be a next time. 2 weeks.
2 weeks, yeah. Because the next 2 Fridays, we're going to miss the next 2 Fridays.
Yeah, if they're all okay.
So some problems for you guys to work on out of the book. You guys just, you remember all the answers are there. You can double check them yourself to see if you got them right. So, yeah, I know. The answers in the back of that book too. In the little book, it's Unit 16, the odds. In the big book, I'm going to have you look at page 175, 176. It's exercise, actually it's 174 through 176. Exercise 5-8A and 5-8B and 5-9. So I'll let you guys have your last 15 minutes here to get started on those.